Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X research and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled Interstellar Space Rock Oumuamua Accelerating Suggests It is a Spacecraft. Now, it has been recently reported that a space rock coming through the inner solar system on a hyperbolic orbit is now moving out of the solar system and is accelerating. A hyperbolic orbit is an open orbit as opposed to an elliptical orbit, which is a closed orbit. An object in a closed or elliptical orbit is in orbit around the sun, and it has been a part of the solar system for a long time, or is an object that came through the solar system and has been captured by the sun's gravitational attraction. And here you see an image of this object. I believe this is an artist's impression. And this is the particular shape of the object as well. It seems to be long and flat. And it has now been observed to be moving away from the sun and accelerating. Now, an object that moves through the solar system in a hyperbolic orbit has not been captured, is therefore clearly only moving through the solar system and must have come from outside it, and may therefore be called an interstellar object. And here's an illustration of the different possible orbits an object in the solar system or moving through the solar system may have. And first of all, we have the circular orbit, and then we have the elliptical orbit. These two are closed orbits. The circular orbit is a special case of the elliptical orbit. And for the circle, we have an eccentricity of 0. And for the elliptical orbit, we have an eccentricity of between 0 and 1. It must be less than 1. Because this orbit, which is a parabola, has an eccentricity of exactly 1. And the hyperbolic orbit then will have an eccentricity which is greater than 1. So we could say that the parabola is a special case of the hyperbola. So these are the open orbits, and this would mean any object moving in an orbit between the parabola and anything else would be in an open orbit, whilst these ones are closed orbits. So both parabolic and hyperbolic orbits are open orbits, which describe the trajectories followed by objects that have not been captured by the sun. In this case, their trajectory is simply perturbed by the sun so that it curves around the sun. The sun's gravitational influence will cause these objects to accelerate as they approach the sun, and they will move at their fastest speed at their closest point to the sun. This point on the trajectory is called periapsis. All objects obeying Newton's gravity, or the gravitational forces discovered by Newton, will move in this way. However, Oumuamua has been found to be accelerating or moving faster as it moves away from the sun. And here is a representation of Oumuamua's orbit. And you can see from its trajectory that the sun seems to have had the effect on it of sharply changing its direction of motion. So it was moving in this direction towards the sun, and as it went around the sun, it made a curve, it made a turn, and it ended up moving outwards in that direction. Now, according to Newton's gravitational law, the object would be moving at its fastest when it is at its closest to the sun. So right here, close to the sun, it would be moving its fastest. Now, we have a system of objects in the solar system that do not obey the gravitational law discovered by Newton. We have named the system the Planet X system of stellar cores, and we see some of these objects here in the sun's corona. They come to the sun, they make a plasma connection with the sun, they absorb energy from the sun, and they stay bound to the sun. Now, the study of these objects as they interact with the sun has led to the understanding that they are depleted in energy and that this causes them to have an extremely low gravitational influence. It has also led to the understanding that the gravitational force which Newton discovered is actually the resultant force between taking into account two interactions which oppose each other. One is the true gravitational interaction, which is dependent on the photon energy inside the particles making up an object, in addition to the mass of the object, and the electrostatic interaction between the outer negative layers. Stellar cores, once they get to the sun, do not leave, but rather stay very close to the sun and absorb energy from the sun. And you may look at article 236 entitled What are stellar cores for more details on that. The fact that the interstellar object Oumuamua did not stay at the sun shows that it is not an energy depleted or dead object and should therefore follow the kind of orbit that obeys Newton's gravity. In other words, it should obey Kepler's laws, since Kepler's laws are a direct consequence of Newton's gravity. However, Oumuamua has been observed to be accelerating as it moves away from the sun, which has prompted astronomers to suggest that it is a comet. In other words, astronomers have stated that this object must be a comet, as then it would be outgassing, and this would explain it accelerating as it moves away from the sun. But this explanation is simply not possible. Comets, like asteroids, do not violate Kepler's laws. Thus, all comets and asteroids, no matter what orbit or trajectory they follow around the sun, be it a closed or an open orbit, will move the fastest at periapsis. The way an object is judged to be a comet is the appearance of the characteristic coma and tail. This object has not developed any such characteristic. If objects that are clearly comets from the size of the comet tails they develop do not violate Kepler's law, i.e. always slow down as they leave the solar system instead of speeding up as this object is doing, how can stating that this object is a comet explain this object's violation of Kepler's laws? In addition, if this object was doing any outgassing that could exert enough of a force to cause the object to accelerate, the gas would be moving away from the object, thus producing a trail, and no such trail has been detected. Any outgassing that remains with the object means that the gas is gravitationally bound to the object and cannot be producing thrust. And any suggestion that this is occurring is tantamount to suggesting that a volcanic eruption on Earth, which places a lot of sulfur dioxide in its atmosphere, affects Earth's orbit around the sun by slowing it down or speeding it up. Also, as James McKenney has discovered and details in his book Planet X, Comets and Earth Changes, comets are in fact the same as asteroids and thus simply rocky objects, which follow a non-circular orbit, which then results in these rocky objects discharging the solar capacitor, or a series of concentric nebular iron clouds centered on the sun. This is the reason why stars have what is termed planetary nebula around them. Planetary nebula are made of positive ions ejected by the star at the center. And you may look at article 254 entitled Planetary Nebula and Death of a Star for more details. And here's an illustration of how a comet moving through a very elliptical orbit or even an open orbit will discharge the capacitor, which is a series of concentric clouds, and there are ions ejected by the star in these clouds, and they will have different weights depending on the distance from the sun. So the heaviest will be in the cloud closest to the sun and the lightest in the cloud furthest from the sun. And a comet coming in will draw a current of ions from the nearest cloud, and it will draw a current of electrons from the sun's outer negative layer, the corona. And this is usually not not seen, the electron current, but the positive ion current is seen when the electrons combine with the ions, and that leads to light emission. And the comet will also develop a coma where the same thing occurs. The positive ions combine with electrons and light is emitted. And it also means that material is coming in towards the object, and it's the opposite of outgassing. So material is being drawn in towards the object, its mass is increasing. In other words, these objects pull positive ions from the sun's nebula clouds and electrons from the sun's corona. The combination of ions and electrons cause light to be emitted from the tail and the coma of a comet. Here's another illustration of a comet where we have the coma, and this would be a dense cloud formed from elements combining as electrons and ions from both currents interact. And the same thing happens in the tail. This is why we can get then neutral hydrogen and neutral oxygen, which then combines to produce water in the tail and in the coma. This is where the water in comet tails comes from. But if they move into another region in a planetary system or in the solar system where there is no hydrogen or no oxygen, then other things will be formed in the tail, such as sulfur dioxide. And you may look at Article 169 entitled Planetary Formation, Comets to Planets for more details. And again, here's Oumuamua's trajectory as it came in. Here it's again quite close to the ecliptic, and we would expect an object in such an orbit to have developed comet characteristics as it moves close to the ecliptic by absorbing material from the nebula clouds and electrons from the sun's corona. So what could be causing Oumuamua to accelerate as it moves away from the sun? An asteroid on a trajectory that sharply deviates from a circular one would be expected to develop comet characteristics, at least when it is closest to the ecliptic plane. And then we would be able to call it a comet. A comet accelerating as it moves away from the solar system would imply that it is accelerating towards another massive object just outside the solar system. But Oumuamua, an object which clearly is not in a circular orbit, has not developed comet characteristics, namely a tail and a coma. So it cannot be a natural asteroid and is therefore likely to be a spacecraft under intelligent control. So if this object had been a natural rocky object, it would have developed comet characteristics, because this is actually what a comet is. The fact that this object has not developed these characteristics means it's not a comet. Now, if it had developed comet characteristics and had been observed to be accelerating away from the solar system, then the only plausible explanation is that another massive object with a large gravitational field would be pulling it in. So another star just outside the solar system. But the fact that it has not developed comet characteristics shows that it's not a natural rocky object. So the only possible explanation is that it is actually a spacecraft and must be under intelligent control, and thus some kind of engine power has caused it to accelerate. So in conclusion, the interstellar object Oumuamua cannot be a comet, as it has not been observed to develop comet characteristics. Comets are simply asteroids in non-circular orbits discharging the solar capacitor. The more the orbit deviates from circular, the more comet characteristics we can expect an asteroid to develop. Oumuamua is in a trajectory which is far from being circular and has not developed comet characteristics, and has furthermore violated Kepler's laws by accelerating as it moves out of the solar system. And this indicates that Oumuamua cannot be a natural rocky object and is therefore most likely a spacecraft under intelligent control. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.